So we're Team 7, and our project we've decided to call the Nikolan Supercharger because, it's like a car, after the whole Cybertruck stuff. Alright, but moving on to more of the specifics, the problem that we are going to be addressing is students trying to carry stuff around campus and them either being too unwieldy or that it is just too cumbersome for them to use. So we decided to make a box that follows them around using remote controls and an ultra distance sensor that automatically stops before it hits anything. And that's why we decided to put it in there, so that it would act autonomously, so that if the student gets distracted, there's still a fail-safe for the remote control car, the Nikolan Supercharger, to stop it. So, moving on to the electronics, we should start with the battery. Our battery is just a simple 4 AA battery array, which we then plug into our motor controller board, which then controls into the Arduino to provide power to the system. The next thing we should talk about is the motor controller board, which is going to be the main brunt, or the second main brunt of our electronics. So these two here plug into our motor here, and then correspondingly these two plug in over to this motor. Then these are connected via the board to these 4 pins, which are then connected to our 2nd, 3rd, 4th, and 7th pins on our Arduino board. Then, in order to provide power, we have our ground pins here, where the ground connects here, and then the ground connects here into the Arduino. And then we have our power going into here. Then, moving on to the Arduino board itself, it just has all the connections where our code commands will be coming from. And it has our Arduino, where we have pins 11 and 8 going to our ultrasound distance sensor. The ground pin for the digital pin coming in here. And then finally, we have our ground pin also for the ultrasonic distance sensor coming in here in order to keep the system grounded. Moving on to the ultrasonic distance sensor, we have our 4 pins here, where pin number 13 is going to be corresponding to our trigger pin, our white one, which was our pin number 11, was our echo pin. Then we have our ground power pins here. Our ground power here, and then we have this blue one here, it's red power. Now, to move on to these motors, we have just our 2 pins here that connect and give power into this gear train in order to drive the system. Now, moving on to the code. First, we have these includes in here for our remote control sensors. However, we've not received them, so we don't know the frequencies, so we haven't defined each break case in order to determine what buttons will be used. Next, we have this duration distance. Obviously, that's going to be defining for our ultrasonic distance sensor. Then we have each of our pins set up. Trig is 8, and then this is 11. Next, we have our left wheel is 1, 2, 3, and 4, which are actually different pins, but we'll fix that later. Next, we have this. This is again for brake cases and our remote control set. Then these pin modes are defined what each output and input it is, and then we have a serial in here. Next, we have our void loop, which is the main brunt of our code, where we have this is our brake case setup if statement. Then we have our finding distance statement, and we defined it. This is defined distance. This isn't necessary to stop it. Then we have our switch inputs, where each case is defined to be a different scenario, where 1 is going to be forwards, case 2 is backwards, case 3 is left, and case 4 is right, where the default is that it is at rest. Then we have our distance code, where it says if the distance is less than or equal to 3, then we have them all set to low in order to stop it. And we decided on 3 because we wanted to give it a little braking room so that it can stop sooner.